Hi you guys, we're going to do geometry 5.3. We're going to prove triangles are congruent with a theorem that's called side angle side, okay? Last class we talked about triangles being congruent. We talked about polygons being congruent. I'm going to talk about triangles specifically today. We said if two triangles are going to be congruent, then all of their parts are going to be congruent. So if triangle cat is congruent to triangle dog, that means all of their corresponding parts are congruent, okay? So I could see I've got CAT, DOG, the order matters, D, O, G, it's easier if we line them under each other. Angle C and D correspond, they are congruent. Angle A and O correspond because of the order it's written, the congruent statement, they're congruent. Angle T and G correspond, they're congruent. It also means the corresponding sides are congruent. So I've got one pair of angles, two pair of angles, three pairs of angles that are congruent. Sorry about the blurry stuff. I don't know. And then all the corresponding sides. So side CA corresponds to DO. These are congruent. One pair of sides congruent. Side CT corresponds to side DG. They're congruent. And side AT corresponds to side OG, and they're congruent. So you have three pairs of corresponding angles and three pairs of corresponding sides that are congruent. Okay, let me see if I can do something. I don't know why it's doing that. Get that further away. Okay, this is a shortcut what we're going to do today. Rather than writing out all three pairs of angles and all three pairs of sides, which is a total of 6 equations, right? 3 pairs of angles, 3 pairs of sides. We're going to shortcut it and do only what's called the side angle side theorem. Here's how it goes. If two sides and their included angle of one triangle are congruent to two sides and their included angle of another triangle, then the two triangles are congruent. So, rather than saying one pair of angles, two pair of angles, three pair of angles are congruent. Yes, ma'am?
How did Valerina do?
Okay. She didn't have her work. So I just had her, she said she lost it all. So I just made her do two-step equations. Okay, so instead of showing all of these and all the pairs of sides, we're only going to do 3 things. One pair of sides, another pair of sides, and the angle that those two sides form, which is called the included angle. So 1, 2, 3, 1, 2, 3. I only have to show 3 pairs are congruent in order to show the triangles are congruent. Okay, so when I do this, I'm going to look at this. I want you guys to see why it's called the included angle. Here's side BA and side AC. The angle that they form is the included angle. Okay? Side ED, side FD, the angle they form is the included angle. So angle B isn't formed by those 2 lines. Angle C is not formed by the 2 highlighted lines. Only angle A, that's called the included angle. Because of this, I know that triangle ABC is congruent to, now look where I'm going. If I go triangle ABC is congruent to, I'm going to start with the angle that it's congruent to, right? So D, I'm going to start with. I'm going A to B. I'm going up this one slash mark. So I'm going to go D to E, and then F. Those two triangles are congruent because one pair of sides, two pair of sides are congruent, and then the included angle are congruent. They're given to me. Okay, so that's called side angle side theorem. Now, what is hard in this section is that we are going to, for the rest of the chapter, we're going to refer to a lot of previous learning. So from our previous learning, we're going to look for parallel lines, especially alternate interior angles being congruent. We're going to use this a good bit, okay? So that's when I have parallel lines cut by a transversal, and I'm saying angle 1 and angle 2. These angles are congruent. Angle 1, angle 2. Sorry, it's kind of little. Remember, alternate interior angles make a Z. We're going to use that a good bit, okay? So your Z angles. We're going to talk about bisecting. We're going to either bisect, we can bisect segments and we can bisect angles. Okay, we're going to use that a good bit. So bisect, we can divide an angle into two congruent angles. We can also bisect means to divide a segment into two congruent segments. Okay. We can talk about doing midpoint. Midpoint is going to be the point that divides a segment into two congruent segments. Okay. Another thing we might be told is that like an angle is a right angle, which means 90 degrees. Okay, those are words that we're going to see that we have to be willing to make, to apply to the problem, okay? We'll see them. I'll show you. Okay, then special symbols. This, instead of just being the words, it might be symbols that we look for in the pictures. Okay, it'll just be in the pictures. So we have to pay attention. We might see triangles with vertical angles. Remember, vertical angles are always congruent. Okay, so for instance, I have two triangles like this. Look for vertical angles. Those angles are going to be congruent. We're going to have shared side is congruent. When something equals itself, it's also the reflexive property, but I care mostly that you guys can see that it's a shared side. So for instance, this side right here, we'll call this CATS. This is a shared side, okay? If I were to split these two triangles, rather than being together, we split them up. Okay, this is ACS. This would be AST. This side has to equal itself, right? That's a reflexive property when something equals itself. So that's because this is a shared side. Look for that in pictures. Again, pay attention. You're going to see parallel lines in pictures. Before I said it might be in the directions, but you might also have a picture and you're told, oops. Okay, I'm going to erase this. I don't want that line there, okay? Sorry. Let me get rid of it. Okay, and I tell you my picture's kind of cruddy, but in this picture, I've got parallel lines, okay? And I say that this line is parallel to this line. When I do that, this can be my transversal, right? And this angle would be congruent to this angle. These are alternate interior angles. See them? The Z? Okay? So we would say this angle is congruent to this angle because you got parallel lines cut by a transversal. Alternate angles are congruent. I could also do it the other way. And here I would have, okay, alternate interior angles congruent. So that's another thing to watch for in a diagram. When they tell you the lines are parallel with a parallel symbol. Okay, look for that. Okay, also look for right angles. So you might just see the right angle symbol. Okay. Okay, remember that would be, let's say I have this, and I've got this and this. That means they're both 90. So they're equal to each other. Okay? You might also just be told, look for perpendicular. Okay? These are going to be, they're the same, but watch for them. Okay? Okay, same thing here. Okay, you guys good? On the back side are examples. I'll talk through some of them. I'm not going to go through all of them, but I'll go through some. Okay? So here we're saying, is there enough information to state that the triangles are congruent using side angle side? So I have to have a side equals a side. The included angle equals the included angle of the other triangle. And then another pair of sides. You have to have three things. Okay? So we're going to look at the pictures. Do I have enough? Okay, right here is a shared side. So if you were to split these two triangles, right? Split them up. I know the shared side has to be equal. I'm told that this side equals this side. I'm told that this one's 90 and this one's 90. So when I look at this, I've got a pair of sides. There's one pair of sides, two pair of sides, and then I have to decide, is the angle given, I've got a 90-degree angle in both of them. Is that the included angle, the angle formed by the two sides? And I look at it and go, yep, that's the angle formed by the two sides, yep. So is there enough information? I would say yes. Okay? When you look at this one, there's a shared side. This one's tricky, okay? On this one, I've got the one mark. That side is congruent to that side, right? Let's get another color here. These are orange. Now yellow. Okay. I've got this side is congruent to this side. Now, this angle is formed by the two sides. It's between. It's the included angle. This angle over here is not the included angle. Okay, so no. These two triangles, there is not enough information to prove that they are congruent triangles by side angle side. This one, when I look at number 4, you're going to see you've got vertical angles here. Okay, see your vertical angles. Number 5 is a shared side, 6 is a shared side. I'm not saying they're all congruent. I'm just saying those are things to look at. Over here, when you're doing these, for each of these 4 problems, state if there's enough information to state that the two triangles are congruent. So this is going to be similar to 1 through 6. It's a yes or no. Then it continues. If yes, write the congruent statement for the two pairs of sides and the one pair of angles needed for the side angle side. Okay, so let's look at, I'm going to pick this one, the fourth one, just because it's different. We haven't done it. Okay, I've got a parallel line, and they're also congruent. Okay, and I've got this side is congruent to this side. So I've got side AB.
Pardon the interruption, I have our bus information for this afternoon. Bus 57 is not in service. Students that ride bus 57 and transfer to bus 34, please wait on the sidewalk at dismissal, and bus 34 will arrive shortly. Students that ride bus 57 home, please remain at the high school, and bus number 7 will return at 4:10. Bus 11 is also not in service. Students that ride bus 11 home, please remain at the high school, and bus 59 will return at 4 p.m. Students that ride bus number 11 to
Hold on, you guys.
Kingsbury, please get on bus 47 at dismissal. Bus 102 is also not in service. Students that ride bus 102 to Critchfield, please get on bus 58 at dismissal. Thank you.
Okay, so if it's going to be the included angle, it has to be the angle at the vertex where these two sides meet. Okay, the angle formed by these two sides. Again, where do these two sides meet? This is a vertex. So that angle at the vertex, this angle would have to be congruent to that angle in order to be the included angle. So, are these angles congruent? Okay, we have these arrows which say the lines are parallel. So if two lines are parallel, cut by a transversal, alternate interior angles are congruent. So this picture here, I'm showing you alternate interior. This angle is congruent to this angle. Take that, slide it up here. Here's your transversal. Here's your two parallel lines. Yes, this is alternate interior angles. So I know this angle is congruent to this angle. Is there enough information? Yes. We can state that the triangles are congruent. So I'm going to say triangle ABC is congruent to, when I start with A and go to B, A matches up with C, right? Oh, that's an E. So E will go under that one, right? A to E. And then I'm going to go to D and C. On the test, it's going to be an answer blank like this, but I'm going to write it under to help me. And then rewrite it. That's my congruence statement, and that's how I got it, okay? I hope that helps. All the rest of this part down here is exactly the same. Decide if there's enough information, okay, to say that these triangles are congruent. You're doing the same thing. Nothing's different. This one, though, your parallel lines, pay attention. Your parallel lines are this way, okay? Okay, thanks, you guys. Have a good day.